Okay, I hope everybody is fine and healthy. We want to do some trigonometry questions. We want to do some problem solving using basic trigonometry. Um, in this first exercise, we have two buildings. They are at a distance of d from one another. One is a shorter building, 120 meters in height, like one of those high-rise buildings in the downtown of the city. And this one is a taller building, and the height of the taller building, we don't know how much that is. Now, a person is standing on the roof of the shorter building and is looking at the top of the roof of the other building, and the angle of elevation of the top of the taller building is 47 degrees. And he also looks at the base of the taller building. The angle of depression is 36 degrees from that point. Given this information, we want to find two things. One, the height of the taller building, and two, the distance between the two buildings. This is a diagram that shows the story of the problem. In every word problem, normally it's like that. They give you some sort of diagram, or you can also draw it. But now we are going to draw a geometric diagram, and we're going to fully label it, and we're going to use that to solve our problem. So I'm going to draw a diagram like this. Of course, the diagram might not be drawn to scale, but I choose point A, B, and C, and this point D here, and I label it 47 degrees, angle of elevation of point B, and angle of depression of point C is 36 degrees. Okay. Other dimensions that we know is this height of point A, which would be 120 meters. So this is 120 meters, side CD basically, and we don't have any other information. Okay, so what we're going to do, we're going to look at the lower triangle first. So we're going to identify the triangle that we're going to write some sort of trig ratio in it. Triangle ADC, very quickly. I'm going to say in this triangle, we want to find side AD. We have side DC. So opposite side is given, adjacent side is required. So I'm going to use the tangent ratio because I don't need AC, the hypotenuse. So I have no reason, no logic to use sine ratio or cosine ratio, but I have to use tangent ratio only. So I'm going to say tangent of angle DAC, DAC, okay, equals opposite side, which is DC, over adjacent, which is AD. So I write the formula, and then I plug in the numbers. So I go tan of 36 degrees equals 120 over, now that distance we called it D, okay? We can call it actually X, just to prevent any kind of confusion. So we call it X. So 120 over X. A simple cross multiplication, we say X times tan of 36 equals 120, dividing both sides by tangent of 36 degrees, which is a decimal number, will give us X equals, so we grab a scientific calculator and divide 120 by the tangent of 36 degree angle, so 165.2. So 165.2, that is the distance between the two buildings. We found our first unknown, okay? And now in the upper right angle triangle, which I have to specify, triangle ADB, the upper right triangle, I'm looking for side BD. Now I can use the info that I found in part A. I know what AD is now, right? So I'm going to say tangent of angle BAD equals opposite BD over adjacent side AD. So that is tan of 47 degrees, which is tangent of angle A. And that is BD, which we don't know, over AD. I just got it earlier. That was 165.2. A simple cross multiplication here. 165.2 times tan of 47 will give us the answer for side BD. So we use a calculator and a tangent of 47 degrees. So 177.1 is what we get. That is the length of BD, 177.1 meters. Okay, but we want to find the height of the taller building. So that is basically BC, which is equal to BD plus DC, if you think about it, the total height. So BD, we just got it, 177.1, and DC is 120. It was given from before. So if you add them up, you get 297.1 meters. And this is actually the total height of the taller building. So the shorter building is 120 meters in height. The taller one we didn't know before. Now we do. It's 297.1 meters. That's the height. And the two buildings are at a distance of 165.2 meters apart from one another. It's a word problem. I don't write it here, but you have to always include a final closing statement or a paraphrase. In this exercise, we have a cell phone tower, and this cell phone tower is connected to the ground using a guy wire. It's a strong wire that holds the cell phone tower. And we have a distance of 18 meters from the point where we have this guy wire attached to the ground. And the length of the guy wire itself is given to be 30 meters. We want to find the angle that the guy wire makes with the ground, basically. Or you can say the angle of elevation of the top of the tower, basically. So again, this is a diagram that explains the story of the problem, but we want to draw a geometric diagram that is fully labeled, and we use that to solve the problem. So I'm going to draw a diagram here. I'm going to say triangle A, B, C, a side AB where the hypotenuse is 30 meters. I include that in my diagram. AC is 18 meters. I include it, and we are looking for angle theta or angle A. So when I look at this right angle triangle, I notice that the adjacent side and the hypotenuse are involved. I have no reason to use sine ratio or tangent ratio where the opposite side is involved. We all know SOHCAHTOA very well. So I'm going to start by writing the cosine ratio. Cosine of angle A is the ratio of adjacent side AC over hypotenuse AB. So we have cosine of angle A, which we don't know, and that is adjacent side, which is 18 over hypotenuse, which is 30 meters. Okay, so 18 over 30, it can be reduced. It's 9 over 15 or 3 over 5. So basically 0.6 cos of A would be 3 over 5, because if you reduce the fraction 18 over 30, it becomes 3 over 5. Okay, 5 times 6 is 30, and 3 times 6 is 18. So 3 over 5 or 0.6. Now, to find angle A, we take the inverse cosine of 0.6, and we need to use a calculator. Inverse cosine button on the calculator, we punch in, and 0.6 gives us 53.1 degrees. So now the puzzle is solved. Now we know that the angle that the guy wire holding the cell phone tower makes with the horizontal is 53.1 degrees. That's the angle that the guy wire makes with the ground. CN tower is there, and there's like sun shining up in the air, and it leaves a shadow on the ground at a particular time of the day. The length of the shadow on the ground, it can be easily measured, with a measuring tape or other tools. 19.5 meters is the length of the shadow, and the angle of depression is 88 degrees. So from the top of the CN tower, if you look at the tip of the shadow on the ground, that angle of depression is 88 degrees. Angle of depression is the angle between the horizontal line and the line of sight below the horizontal line. So some people by mistake, they think that angle of depression is the angle that the line of sight makes with the vertical, by mistake, but it's not true. It's the angle between the horizontal line and the line of sight below the horizontal line. So by looking at the diagram and remembering Z pattern alternate angles, it's not difficult to understand this other angle here must also be 88 degrees. Of course, the diagram is not drawn to scale, but that's not important. So the measure of this angle is 80 degrees. Alternate angles are equal. And we do have another triangle here. So this is the triangle. I should have drawn it the other way probably. Okay, so it's like this. And 19.5 is the length of the shadow. The angle is 88 degrees. We want to find the height of the CN tower, which is that height H. I label it as always, so I go A, C, B, and in this triangle, I have a opposite side, which has to be found. I have the adjacent side, which is given, and I'm thinking which trig ratio involves opposite and adjacent. Obviously, is tangent. So that's the logic behind using the tangent ratio in this exercise. So I go tangent of angle B equals opposite over adjacent, which is BC, and that gives you H over 19.5, and the angle is 88 degrees. So by cross multiplying, we can calculate the height of the CN tower, and that is 19.5 times tangent of 88. So 558.4, roughly 558.4 meters. So that becomes the height of the CN tower given the shadow on the ground. Okay, so you know that it's a tall tower. You don't need to measure it using a measuring tape. It's impossible. But using your knowledge of trigonometry with your power of mathematics, by just simply measuring the angle of depression and the length of the shadow on the ground, you can easily calculate instead of measuring the height of the CN tower. That's one application of trigonometry, basically, that you can calculate inaccessible heights, basically. This other one is a tree. We have a tree, and the sun is shining up there and leaves a shadow on the ground. The shadow is 3.8 meters. You can measure it with a measuring tape. The height of the tree is 9.8 meters. And what we want to know is what is the angle that the sun rays are basically hitting the ground with that angle. Okay, so the angle of basically you can say depression of sun, that's what we want to calculate. So again, we have this right angle triangle, A, B, C. The angle theta needs to be found. 9.8 meters is the height of the tree. 3.8 meters is the length of the shadow on the ground. And this time we're looking for the angle, but again, opposite side and adjacent are involved. So we have to use the tangent ratio. So we go tangent of angle A equals opposite side, which is BC, over adjacent, which is AC, and that is 9.8 over 3.8. And from there, we find this ratio. We use a calculator. We divide them. The ratio is 2.5789, 2.5789 approximately, 473. You can include more digits if you want. So angle A would be the inverse tangent of this figure we just got. So inverse tan of 2.5789473, that would be the angle with which the sun rays hit the ground. So we take the inverse tangent of what we just got, and it's 68.8 degrees, roughly 69 degrees. So we see that the angle of depression of sun rays is 69 degrees roughly, rounded to the nearest degree. So you see that by using your knowledge of trigonometry, you can solve a variety of problems guy wires, cell phone towers, height of inaccessible heights like CN Tower, finding measures of angles in different diagrams given the shadow, finding heights of buildings, and all sorts of problems can be solved using your knowledge of trigonometry. And all you have to do is just keep practicing and doing more and more and more questions. I think I'll give you more examples in another lecture, and that will be enough, I would say. Thank you.